Objective 2.3 for Calc BC. We're dealing with the absolute max-min, so the highest elevation and the lowest elevation. Now, every continuous function that's on a closed interval will have an absolute maximum and an absolute minimum. Now, is it possible for a continuous function that's on an open interval? Yes, it's possible, but to guarantee that you will have an absolute maximum and an absolute minimum, it needs to be a closed interval and also a continuous function. I mean, there are exceptions where you don't have to have those situations, but to guarantee that it's going to happen every time, it needs to be continuous on that closed interval. Where do we look for absolute extremum? They can occur at the critical points, so like a relative maximum could be actually the absolute maximum, or a relative minimum could be the absolute minimum on a closed interval. So we check the critical points and we also check the endpoints as well. Okay, let's do an example. Find the absolute extrema for this function y equals x to the third minus 3x squared plus 2 on the closed interval from -2 to 4. Okay, now we need to test critical points on the interval, and we also need to test the endpoints, and it doesn't really matter which ones you test first. Let's just go ahead and do the critical points first. So dy dx is 3x squared minus 6x, and so if we set that equal to 0, we get critical points of 0 to 2. Okay, now we don't really need to test to see if they're a relative min or a relative maximum. We're going to just compare them against the endpoints. So what do I mean by that? Well, I'm going to find the y value that's associated with these two x values. So if I do y of 0, so I get 0 cubed minus 3 times 0 squared plus 2, which is 2. So at x equals 0, I get 2. Okay, now I'm going to do the same thing with 2. So y of 2. So 2 cubed, 8, minus 3 times 2 squared, plus 2, which is -2. Okay, so at the moment, 2 is my highest elevation, and at the moment, -2 is my lowest elevation, but we do need to check the endpoints. By the way, sometimes the critical points could be the endpoints as well, so that happens. Also just watch out, just in case any of the critical points are outside of the interval, don't test them because you're only going for critical points that are within the interval. Okay, so these are the critical points and they line up with the dy dx. Now let's advertise what's going on here. So endpoints, checking endpoints. So I'm going to do y of -2. So -2 cubed minus 3 times -2 squared plus 2, which is -18. Well, I would say that -2 is no longer the absolute minimum, and -18 is a good possibility that it is. But let's check out the 4. Y of 4. So 4 cubed, 64, minus 3 times 16, so minus 48, plus 2, which, let's see, that's 18, positive 18. Okay, so out of my critical points that were on the interval, and my endpoints, which one is my highest elevation, which one is my lowest elevation? Well, my highest elevation is the positive 18, so this is the absolute maximum on this closed interval. And it occurs at x equals 4. And in a similar way, negative 18 is my lowest elevation. And so this one is my absolute minimum on this closed interval. And it occurs at x equals negative 2. So the minimum or maximum is actually the y value. Where it's happening is the x value. Okay, let's try one more here. Trig, we got to deal with trig because sometimes trig comes up. When it comes up, we got to deal with it. So let's see. Let's try the endpoints first this time, just because. Endpoints. Advertise what you're doing. Y of 0. 2 times cosine 0 plus cosine 2 times 0. Cosine 0, of course, is 1. So this is 2 times 1 plus 1, which is 3. Okay. And y of pi, which is 2 cosine pi plus cosine 2 pi. Excuse me. Cosine pi is negative 1. 2 times negative 1 is negative 2 plus, okay, cosine of 2 pi. Well, cosine of 2 pi is the same thing as cosine of 0, which is 1. And so this is negative 1. Okay, now let's go ahead and find our critical points now. So dy dx, we've got negative 2 sine x minus 2 sine 2x, and we're going to set that equal to 0. Let's see, there is a GCF of negative 2, which is not changing anything, really. And so the negative 2 is not really affecting our critical points at all. I'll just kind of keep it going along the way anyway. Let's see, sine 2x, we need to know our trig formulas. And so now there's a GCF of sine x. And so negative 2 sine x equals 0, 1 plus 2 cosine x equals 0. So this would be sine x equals 0. Well, sure. X equals 0 pi. Oh, okay, so those are our endpoints anyway. We already tested these endpoints. Okay, subtract 1 divided by 2, cosine x equals negative 1/2. Okay, so that's the x quadrants 2 and 3, and that's a reference angle of pi over 3, so 2 pi over 3 in quadrant 3 and 4 pi over 3 in quadrant 2. 2 pi over 3 in quadrant 2 and 4 pi over 3 in quadrant 3. So we need to test those now. So let's see, if we do y of 2 pi over 3, we get 2 cosine 2 pi over 3 plus cosine of 2 times 2 pi over 3, which is really 4 pi over 3. is cosine of 2 pi over 3? Well, it's negative 1/2. And what is cosine of 4 pi over 3? That is also negative 1/2. So we've got negative 1 plus a negative 1/2, which is negative 3/2. Okay, last one to test. But wait a minute, 4 pi over 3. Is 4 pi over 3 in this interval? No, it's outside of that interval. So therefore, we've tested the last one that we need to test. Okay, so let's look at our three values. We've got the values for the two endpoints, 3 and negative 1, and we've got the value at the one critical point that was actually in the interval, and it's negative 3/2. So our absolute minimum is negative 3/2 at x equals 2 pi over 3, and our absolute maximum is 3 at x equals 0. Okay, one more problem here. Okay, so we have a function y equals x over 1 plus absolute value of x. Find the absolute max and min. Okay. Well, maybe let's get it taken care of so we don't have the absolute value to deal with, for one thing. Let's remind ourselves what the definition of absolute value is. Absolute value of something, absolute value of x is equal to x if the inside is non-negative. And it's equal to negative 1 times x if the inside is negative. Okay, so looking at the absolute value over here, what's kind of the dividing line? What makes it 0 inside the absolute value? Well, 0. So that's the dividing line. So y equals x over 1 plus absolute value of x is equal to, we're going to do a piecewise function. So x equals 0 is the dividing line. So let's see, x less than 0, x greater than 0. Okay, now, which one's the positive? Usually it's the greater than, but we can test it. So if x is greater than 0, those are positive numbers, the inside is positive. So the equal sign should go with the positive rule every time. Okay, so if x is less than 0, we're going to multiply the inside by negative 1. So this becomes x over 1 plus negative 1 times x, so 1 minus x. And if the inside is greater than or equal to 0, then we just drop the absolute value bars and we're left with x over 1 plus x. Okay, so let's do a quick sketch of the graph here. Okay, now for the values of x that are going towards negative infinity, what's the limit of this expression as x goes to negative infinity? Well, it's x over negative x, and so therefore it's negative 1. And what if we're going to positive infinity? Well, it's positive 1. And let's see, what if it's equal to 0? Well, 0 over 1 plus 0 is 0. Okay, so as it goes to the left forever, it's going towards elevation negative 1. As it goes to the right forever, it's going to elevation positive 1. So it's doing something like this. Okay, now when we're dealing with infinities, it's a little bit mind-blowing. So, but what's the absolute maximum? Absolute maximum is 1. Where does it occur? Well, theoretically, if we keep going forever, it reaches elevation 1. And what's the absolute minimum? Well, if we go out to the left forever, negative 1. Now we can't actually put our finger on what x value it is where it occurs, but you know, if we're going to the right forever, it goes to elevation 1. If we go to the left forever, it's going to elevation negative 1.